British astronomer Richard Carrington was observing the surface of the sun with his telescope when he suddenly noticed something strange. Two spots of bright white light. It's 1859. People are on the street, working on farms, collecting the fruits of their labor. Life is not like it is now, more nature, less technology. Science is developing, but even a light bulb has not yet been invented and will be invented in 20 years. At that time, the astronomer did not know that he was observing what would later be called the Carrington event, the largest solar storm ever recorded. This was the first solar flare that we saw and paid attention to. And she brought so many unusual things. The auroras were just amazing. That year they were the most intense in 160 years. Auroras mostly appear near the poles of the Earth, which reflects their name. But in those days they could be seen even near the equator. They spread across the sky everywhere from Australia to Canada. If you were in the tropics, for example in Panama, Jamaica or Cuba, you would also be able to see the auroras. It was an impressive sight. The luminous waves reached the zenith, and some were large enough to cast a shadow on the ground, and they were very bright. In the state of Missouri, you could be reading a book in the middle of the night without extra light. The glow was so strong that gold miners in the Rocky Mountains woke up, cooked eggs with bacon and brewed coffee without any questions. They thought that the sun had risen on a cloudy morning, although it was 1 o'clock in the morning local time. But this extremely strong solar flare led to power outages from Boston to Paris and charged telegraph lines. There was so much electricity in the air that telegraph machines could send messages from Pittsburgh to New York without batteries. In Paris, sparks even flew from the telegraph machines. And now there are growing fears that another powerful solar storm is coming in 2025. It can lead to massive blackouts of electricity, light, and internet in entire cities, possibly for months or years. Today we depend on electricity much more than then. We are talking about devices not only in our homes, but also in hospitals and other places where technology is simply necessary. Electricity is needed for the production and storage of food. We also need it for everyday activities, such as work and communication. Another solar storm of such magnitude as the Carrington event could cause trillions of dollars worth of damage to Earth. In the United States alone, up to 40 million people will be without electricity for several years. What are solar flares? These are the biggest explosive events that occur in the solar system. Magnetic energy accumulates in the sun. Bam! With an intense burst of magnetic energy, a solar flare occurs. This throws out waves of energy that move and spread outward. Of course, this affects other bodies in the solar system, including the Earth. And when electromagnetic waves interact with the magnetic field of our home planet, several things happen. First of all, we receive electric currents in the upper layer of the atmosphere. They heat the air as if the Earth receives its own electric blanket. At this stage, you can see stunning auroras. At the same time, GPS and radio signals are disrupted. As our atmosphere heats up, it swells like a marshmallow, and satellites in low orbits encounter a lot of resistance. When expanding, the atmosphere pushes them down to the surface of our planet. It also throws small fragments of space debris off course. When strong electric currents pass through the upper layers of the Earth's atmosphere, they affect the currents passing through the crust of our planet. This can spoil the electrical conductors on the Earth's surface. For example, power grids, through which electricity is transmitted from generating stations to different buildings. This leads to power outages, which can be difficult to eliminate. As for example in Quebec in March 1989, a powerful flash occurred on the sun. Soon after, another flare spewed 1 billion tons of gas towards our planet. Quebec was left without electricity for 12 hours. Just a couple of months later in August, another solar flare headed for our planet. It was a speed of millions of kilometers per hour. Thus, solar storms emit radiation, and coronal emissions emit plasma. Together they emit particles and radiation. When in contact with the upper part of the atmosphere, all this forms radio waves. We call them geomagnetic storms. They cause new currents and supply power to electrical networks that are usually passive, which can lead to overload. Take for example the electricity coming out of the socket. Its frequency is about 50 Hz and may vary slightly depending on the country where you live. Radio waves are usually transmitted at a frequency of 85 to 105 million Hz. Gamma rays and X-rays have a frequency of up to 50 quintillion Hz. Solar radiation is also radiation that uses your phone for power, only several billion times stronger and uncontrolled. Researchers believe that a powerful solar storm could hit us in 2025. These storms reach their peak every 11 years. Mostly we are lucky and they bypass us, but we cannot expect that luck will last forever. Now we have a chance of about 2 to 3% that something like the Carrington event will happen in this decade. In this case, it will take us up to 10 years to eliminate the consequences. Humanity will be thrown back almost 20 years if this happens. All these crazy particles can damage our satellites. As a result, we will lose communication, no television, no internet, no GPS. We will be dealing with very strong radiation. There is a possibility that people will face long-term problems because of this. What can this amount of solar radiation do to our DNA? This is especially true for those who are not protected by the magnetic field of our planet, such as astronauts. Humanity may try to protect the internet from the next powerful solar storm. First of all, it is necessary to strengthen the power grid, underwater cables and satellites in case of overload. We can look for methods to predict such storms in the long term. This is difficult because these storms have been happening for millions of years, and we have learned to record them only in the last 100 years. In addition, the technology affected by storms has only been around for 2 decades. We can observe sunspots, black spots on the surface of the sun, which tell us that this area is with high plasma activity. By testing them, we can predict solar storms 2 days before they hit our planet. But they can't be tracked, because we track hurricanes. Hopefully by 2025 we will find a reliable way to avoid a future without the internet. Although it would be great to take a break from social networks, isn't it?